Audio review of textbook for Class 12. Practical work in Geography Part 2. Chapter 1. Data. Its source and compilation.
All right, welcome back to the deep dive. Today, we're going to be looking at data, kind of like where it comes from and how we make sense of it. I got some really interesting sources here. A lot of it is focused on geography, but the ideas, I think, apply to tons of other stuff too. So yeah, we're basically trying to make this whole data thing, a little less mysterious.
Yeah. I think a good way to look at data is like raw materials, like the numbers themselves. The sources talk about things like, how much rain falls in different parts of India or like distances between cities. That's like data in its most basic form. But it becomes information when we like actually use those numbers to figure stuff out.
So why is all this data stuff so important?
Well, I mean, if you want to understand like patterns like where crops grow best or how cities grow, it all starts with data, right? And the sources really make it clear that like, and in geography at least, understanding how different things are connected, like the climate, the number of people, how land is used, all that stuff relies on, good data. But it's not just about the numbers themselves, right? Like you could have a river that's like on average a safe depth, but there might be like deep spots hidden in it.
Oh,
So that's a kind of like statistical fallacy where the average doesn't tell you the whole story. That's why, handling data properly from the way it's collected to the conclusions we draw is super important.
Okay, so let's talk about where we get data from in the first place. I mean, there are like two main ways, right? Primary data is what you collect yourself.
Yep.
Secondary data is like stuff you find in existing sources. Let's start with primary.
Primary data is all about, firsthand information. One way to get it is through personal observation, like actually going out there and observing things directly, like different landscapes or how people live in a certain area. But you need to like be observant and have a scientific mindset for that.
Right, and then like there are interviews. That's where you talk directly to people to get their perspective, right? It's important to, be clear about what you want to learn, build trust with the people you're interviewing, and ask questions in a way they can, easily understand.
And then you've got like questionnaires and schedules, which are, kind of similar. They both use written questions.
Yeah.
But like a questionnaire is filled out by the person themselves. So that usually means they need to be able to read and write.
Okay.
And then like a schedule is where someone else, like an enumerator, asks the questions and fills in the answers. This lets you get data from people who, might not be literate.
Oh, I see. That makes sense. And then there are direct measurements, using tools and equipment in the field to, test stuff like soil and water quality kits or sensors that monitor crop health.
Right, exactly. Okay, so now let's switch gears and talk about secondary data, where, the information's already been collected. And this can be either published or unpublished. Published sources are, stuff that's out there for anyone to access.
So a big category here is like government publications, right? Things like the Census of India, which is a huge survey of the entire population, or national survey reports and weather reports. These are all packed with official statistics.
And there are also publications from organizations that are like partly run by the government, like urban development authorities or municipal corporations. And then internationally, you have organizations like the UN that publish data on like global population health, that kind of thing.
Yeah, and we can't forget like private organizations, newspapers, magazines, and like huge amount of information available online. Those are all examples of published data.
And on the flip side, unpublished sources are things like government records at a local level, like land ownership documents or like reports from local councils that, haven't been widely distributed, even internal documents from companies or community groups.
Right. Okay, so let's say we've got all this data. Like, what do we actually do with it? We got to organize it somehow, right? To like actually understand it. Our sources talk about things like statistical tables, which are just, ways to like summarize data and make it easier to compare.
Yeah, exactly. And there are different ways to present the data too. You can have like absolute data, which is just the raw numbers, or you can calculate like percentages or ratios to compare things on a, common scale. And then you have index numbers.
Yeah.
Which are really useful for tracking change over time, like, how the cost of living has changed in a certain place. It's like a benchmark to measure change against.
Our sources also talk about processing raw data by like grouping it into classes or categories. And this helps you see patterns in like how the data is distributed.
Yeah.
And they use tally marks to like count how many data points fall into each group. and they call that a frequency distribution.
Right. And from that, you can calculate the simple frequency, which is just, the count for each group, or the cumulative frequency, which tells you how many data points fall below a certain value. This gives you a quick sense of like the overall distribution. And there are different ways to define the groups, like the exclusive method, where the upper limit isn't included in the class,
Yeah.
and the inclusive method where it is.
And finally, there's the visual side, right? Visualizing the data with graphs and stuff. Frequency polygons help us compare different data sets. And ogives, which use cumulative frequencies, those give us another way to see the distribution, like how many data points fall below a certain point.
And this all brings up a really important question for all of us. Like, with all this data out there, how do we make sense of it? What skills do we need to, cut through the noise and understand it all? And think about the data you encounter every day, both the stuff you seek out and the stuff that's thrown at you. What are those primary and secondary sources that are shaping your understanding of the world?
Yeah, that's definitely something to think about. And that wraps up another deep dive. We'll see you next time.
See ya.
Chapter 2. Data Processing.
All right, diving in today, getting into some, pretty fundamental stuff when it comes to working with data. We're talking about measures of central tendency, which, it might sound a little jargony, but we've got some great material that breaks down these statistical techniques. And our goal today is to really get a handle on how the mean, the median, and the mode, these different measures, help us figure out that one, that single value that can kind of represent a whole bunch of data.
Yeah, absolutely. I mean, think about it, right? You've got tons of numbers, tons of observations, and you want to get a sense of what's typical. What's that central value that kind of sums it all up? Our sources actually go deep into the mean, median, and mode. They lay out the formulas, the math behind it all. And they've got some really cool real-world examples, too, showing when to use each one.
So, we throw around this term central tendency. It sounds a little, academic. But what does it actually mean in a practical sense? Why should someone care about this if they're just trying to, make sense of some information?
Well, imagine you're trying to describe the typical height of people in a city or, the temperature of a room throughout the day. Central tendency gives you that one number, that single number, that acts like a best guess. It helps you cut through all the noise, all those individual data points, and gives you a feel for the big picture.
Okay, let's start with the mean. Most people know this as the average, right? But what's important to really understand about the mean?
Well, the mean, you calculate it by adding up all your values and then dividing by the number of values you have. It's simple, straightforward. But here's the thing. It can be really sensitive to outliers, those really high or really low values.
Yeah, and one of our sources actually uses this example of rainfall in the Malwa Plateau in India. They've got figures for 7 different districts. And when you add up all the rainfall amounts and divide by 7, you get a mean of about 926 millimeters.
Now, what's interesting is that this source also talks about a shortcut for calculating the mean, especially when you're working with large data sets. It's called the indirect method, and it basically just simplifies the math a bit, makes it easier to handle, but the basic idea is still the same, summing everything and dividing by the count.
Okay, and what about when we have group data? If we were looking at factory worker wages, but the wages are given in ranges, not individual values, how do we find the mean then?
Right. So with group data, what you do is you use the midpoint of each wage range, like let's say the midpoint between 50 rupees and 70 rupees. And you use that midpoint as a representative value for all the workers within that range. So you multiply the midpoint by the number of workers in that range, and you do that for each range. Then you add all those products up and divide by the total number of workers. And in our example, they actually go through this calculation, and it ends up giving a mean wage of 102.6 rupees.
Okay, so that's the mean, the sum, and divide average. Now, onto the median. This is the value in the middle. What's the key idea here?
So the median is literally the middle value when you arrange all your data from smallest to largest. Like literally, it splits the data set right down the middle. And the big advantage here is that it's not really affected by those really high or really low values, those outliers.
And in our sources, there's this example with mountain peak heights. When you list those heights in order, the one right smack in the middle is 872 meters. That's your median. And, this can be really useful when you're looking at something like housing prices, where, you might have a couple of really, really expensive mansions that could really skew the mean, make it seem higher than it actually is. The median kind of cuts through that and gives you a more realistic idea of what a typical house actually costs.
Exactly. And for grouped data, there's a specific formula that helps you figure out where that middle value, that median, falls within those ranges. It takes into account what we call cumulative frequencies, like how many observations fall below a certain point.
hmm
And in the example we have here, they use that formula and find that the median wage is 82.5.
Okay, so mean is sum and divide. Median is the middle value. Now, what about the mode? That's the one that shows up the most often, right?
Absolutely. The mode is just the value that appears most frequently in your data. You could have a single mode, meaning one value appears most often, or you could have two values that tie, making it bimodal. You'd even have three or more, making it trimodal or multimodal. And sometimes you might have no mode at all, meaning all values appear the same number of times. Our sources have some good examples of this, like a particular test score that shows up multiple times, making it the mode.
So we've got these three different ways to find a central value. How do we know when to use one over the others?
It really comes down to the nature of your data. If your data is pretty symmetrical, meaning it's kind of evenly distributed around the center, then the mean, median, and mode are probably going to be pretty close to each other. But if you've got outliers, those extreme values, then the mean can get pulled in one direction or the other. The median is much more resistant to outliers. And then the mode, that's really useful when you just want to know what's the most common value, what appears most frequently.
And I think our sources briefly mentioned this idea of skewed distributions. This is when your data isn't symmetrical. Like if you have a lot of values on the lower end and then a few really high values, that's what we call a right skew or positive skew. And in those cases, the mean tends to be higher than the median.
Yeah.
And if you have a left skew, where you've got a few really low values pulling things down, then the mean tends to be lower than the median.
Yeah, exactly. That's a good point. So understanding the shape of your data, understanding whether it's symmetrical or skewed, that can really help you choose the most appropriate measure of central tendency.
Okay, so to wrap up, we've got these three tools, the mean, the median, and the mode, each offering a slightly different way to look at the center of our data. And which one we choose really depends on what we're trying to highlight, what we want to emphasize.
And this brings us to a really interesting question. Think about real-world scenarios, like let's say income distribution or maybe website traffic. These are situations where you often have a few really, really high values. So how would those outliers, those really high earners or those websites with tons of traffic, how would they affect the mean compared to the median? And which measure do you think would give you a more accurate picture of the typical value, the typical income, or the typical amount of website traffic? That's something to really ponder.
Chapter 3. Graphical Representation of Data.
All right, welcome back to the deep dive. Today, we're really going visual, talking about how to represent data, but not with those boring tables and texts.
Yeah, I mean, who wants to stare at spreadsheets all day, right?
Absolutely not. You shared this chapter, and it really digs into some fascinating ways to bring data to life. And it's all about showing why visuals are so powerful, actually showing the data instead of just talking about it. So we're going to explore some of those key types of representations.
That's right. The chapter covers everything from those familiar ones like your line graphs and bar diagrams all the way to things like flow maps and even different types of thematic maps.
Right.
It really is, like you said, about finding the right picture to really bring that data to life.
Okay, yeah. So right away, like just starting out, the chapter really emphasizes thematic maps.
Yep.
And it says, that visual impact is just immediate. You don't have to wade through a bunch of numbers to understand what's going on. It even brings up, that classic saying, a picture's worth 1,000 words, right? And that's just highlighting how much faster and how much better we understand and remember something when we can actually see it.
It's true. And it's all because of how fast our brains process what we see.
Right.
It's just way faster than trying to decode a bunch of numbers. Think about it. If you had to compare the population density of different regions, would you rather try to do that by reading a table of figures, or would you rather just look at a heat map and have it jump out at you? I mean, it just makes sense.
Oh, yeah, absolutely. And I think the thing that's so powerful is that it sticks with you. I mean, you see that visual and it stays in your mind a lot longer.
Absolutely.
So when we're actually creating these visuals, what are some of the fundamental things we should be thinking about?
Well, the chapter kind of boils it down to a few key ideas. And the first one, probably the most important, is picking the right type of graph.
Right, because, a line graph is really good for showing trends over time, like, say, temperature changes, whereas a bar diagram, that's going to be your go-to when you want to compare different distinct values. So, like, sales figures for different products or something.
Right.
And then, of course, when you're talking about geographical distribution, like, that's where your dot maps and your choropleth maps really shine. It really is about matching the right visual to the data and the message you're trying to convey.
Makes sense, like picking the right tool from a toolbox.
Exactly.
So what about the design itself? What should we be thinking about there?
Oh, well, I mean, clarity is king, right? That's
Yeah.
kind of the overarching theme. And the chapter really stresses the importance of scale, making sure it's appropriate and accurately reflects the data.
Okay, yeah.
Because you can imagine having a graph where the scale is so squished together that you can't even really see the differences, or it's so spread out that it makes tiny little fluctuations seem enormous, right?
Right. So that's really important. And then you have those basic elements that everyone always forgets. A clear title, so people know what they're looking at immediately, a legend to explain all those symbols and colors, and of course, if you're working with maps, you got to have a north arrow so people can orient themselves.
Absolutely.
Those little details, people often overlook them, but they're absolutely crucial for clear communication.
Right, they make all the difference. So maybe let's dig into a few specifics.
Okay.
What about line graphs and polygraphs?
Well, a line graph usually tracks a single variable over time. So,
Yes.
maybe a country's economic growth year by year. And the chapter even uses the example of India's population growth over time.
Mm-hmm.
And a polygraph, what that does is it takes multiple lines, each representing a different variable, and puts them on the same axis. So you can compare them directly.
Okay.
And a example of that would be like comparing male and female literacy rates across, say, several decades, and you can see those trends side by side.
Right, okay. Now, bar diagrams feel pretty intuitive, but the chapter kind of breaks them down even further, right?
It does. It goes into some more advanced ways to use them. You have your simple bar diagram, which is just comparing single values, but then you can have compound bar diagrams. And what those do is they segment each bar to show different components that make up that total.
Yeah.
So think of it like a company's revenue, but then each bar is broken down by, say, their different product lines.
Oh, okay, yeah.
And then you have multiple bar diagrams, and that allows you to compare like two or more related values for the same categories. So you could be looking at, I don't know, the sales of two different product lines, but across different regions. You can see how those stack up against each other.
Yeah, that makes sense. Okay, so pie diagrams, those are all about showing parts of a whole, right?
It's
So
pie.
like market share for different companies, something like that.
Yeah, that's a great example. And the chapter reminds us, it's really important to remember that the size of each slice directly corresponds to the percentage of the total.
Yeah.
It even gives you the formula to calculate the angle for each slice, so you make sure it's accurate.
Oh, wow, yeah, the detail.
Yeah, the details matter.
Okay, flow maps. Now, those sound like they're about visualizing movement, right?
Exactly. These maps illustrate how things move. That could be people, goods, information, anything really, between different locations. And the chapter uses the example of train traffic density on different routes.
Okay.
And it's pretty simple. The thicker the line, the more traffic there is. And it just gives you this immediate sense of where the high and low flow areas are.
Gotcha. Okay, and finally we get to thematic maps. And that includes things like dot maps and choropleth maps. How do those show us regional patterns?
So thematic maps, those display data across geographical areas. And with dot maps, you use individual dots to represent a specific quantity of something. So that could be population distribution, for instance. And then choropleth maps, they use different shades or colors within those administrative boundaries, like state lines, to represent the intensity of the data. So you'd be looking at unemployment rates across different states, and you'd see, darker colors where unemployment is higher. The chapter highlights how these maps instantly reveal those spatial variations in the data.
Okay, so it sounds like, kind of the core message here is that visualizing data takes it from just being numbers on a page and turns it into these insights that we can understand, that we can work with. We can spot trends, patterns, things like that way faster than we could by just staring at rows and columns of numbers.
Absolutely.
And each of these visuals, has its own strengths depending on the kind of information you're dealing with.
Exactly. Choosing the right visual is absolutely key to being able to communicate clearly and effectively. It's about, like we said before, using the right tool for the job, making that data work for you, making its story clear and easy to understand at a glance.
So, for everyone listening, Think about the data you encounter in your own lives, or even information you want to share. Could a line graph show you a trend you've been missing? Could a bar chart make a comparison really hit home? What about a map? Could it highlight a spatial pattern that you hadn't even considered?
Right.
It's worth thinking about how these tools, these visual tools, could help you better understand and communicate information. Thanks for diving in with us.
Chapter 4. Spatial Information Technology.
All right, so today we're going deep on spatial information technology.
SIT.
Yeah, SIT. Um, and, we've talked about mapping before, but this is about way more than just making maps.
Oh, yeah, for sure.
This is like the tech that helps us understand not just what's somewhere, but like the why behind it.
Right, like the why is it there?
Exactly, so we can use this information to make better decisions.
Absolutely. And SIT is really bringing together all these different tools. Like it's a real melting pot of tech.
Okay, so break it down for me.
Well, you got remote sensing, think satellite images giving us that view from above. Then there's GPS giving us that pinpoint location accuracy. And then GIS comes in and takes all that information.
GPS, okay, got it. Yeah.
Yeah, so GIS layers it all together and lets us analyze it. And then we have digital cartography to help us visualize it all. And of course, underlying it all, we got the databases, keeping everything organized.
So GIS, Geographic Information Systems, that seems like the heart of it.
It really is.
It's not just about storing locations, it's about connecting those locations to all sorts of other information.
It really is.
So we can actually use it to, make smarter choices.
Exactly. It's like the system, designed to capture, store, check, combine. You can even play with it,
Okay.
analyze, and then show you that data. And it's all tied to specific locations on Earth.
So it's more than just pretty pictures.
It's much more than that, yeah.
Right.
At its heart, it's a computer database that knows where everything is, and it's powered by some pretty amazing software.
Powerful stuff.
It is, for instance, it can help predict flood risks by looking at elevation data and rainfall patterns. So there are real tangible outcomes here.
And what strikes me is just how many different fields are contributing to this.
Yeah, it's incredible. It's not just geography and computers.
So who are the players involved?
Well, you've got the computer science folks, they're building the systems. Then you have statisticians providing the tools to analyze the data. You've got cartographers thinking about how best to visualize it.
It's a team effort.
It really is. Then you have those in remote sensing gathering the raw location data, database experts, keeping it all tidy. And then people in all sorts of fields like geography, geology, farming, environmental science, even public administration using it to solve real-world problems.
Wow, that's a lot of people.
It's a real meeting of minds.
Now, the sources mention two main types of geographical information: spatial and non-spatial data. What are those?
Okay, so think of spatial data as the where. The location, the shape, whether it's a point like a tree, a line, like a road, or an area like a lake.
Okay, so that's spatial data, the where.
Right. And then non-spatial data, that's the what, so the information about those things.
I see.
Like, for example, a list of items in a shop's stock register that's non-spatial, because those items could be anywhere.
Okay.
But if you have a map showing the population density of different neighborhoods in a city, that's spatial because the population data is tied to those specific locations.
So the location is key.
Location is everything. Yeah, it's the glue that holds it all together.
And before you can even put this spatial data into a GIS, it needs to be linked to a coordinate system. So how does that data even get created in the first place?
Well, there are basically 3 ways you can buy ready-made digital data from companies that collect it.
Okay.
You can take old paper maps and convert them into digital formats. That's called digitizing.
Like scanning them in?
Exactly. Or you can go out and conduct your own surveys to collect the specific location information you need.
So you've got options.
Yeah. The best way really depends on what you're trying to do, how much money you have, and whether you're working with grid-based data, that's raster, or feature-based data, which is vector.
And a lot of this initial spatial data comes from maps, right?
Oh, absolutely.
Like your standard road map or a map showing different types of soil. What are some of the important things to know about using maps as a source?
Well, maps, whether they're on paper or digital, all have a defined scale, so you know how much the map has been shrunk down compared to the real world.
So it's all to scale.
Exactly. They also use symbols and colors, as a kind of shorthand to represent different things.
Okay.
And importantly, they all use a coordinate system. Think of it like a street address for every point on Earth, so you know exactly where things are.
So we've got this powerful GIS technology built on location data and descriptive information, often starting with maps. What makes this so much better than the old manual ways of doing things?
The advantages are huge. First, you can ask a specific location, what are you, and instantly get all the information associated with it.
Wow.
Second, you can flip it and say, show me all the areas that match this description, and it'll generate a map for you.
Amazing.
Third, you can perform some really complex spatial operations, like combining different maps to find new patterns or creating buffer zones around features to see what's nearby.
So you can really dig deep with this.
Oh, yeah, and finally, it lets you connect all sorts of different information just because they share the same location.
That's fascinating. You mentioned combining maps.
Mm.
Can you give me an example of how that works?
Sure, imagine you have one map showing different types of vegetation and another showing soil types.
Okay.
By overlaying them, you can identify areas where a specific type of vegetation grows best in a particular soil.
I see. So you can start to see patterns.
Exactly. Another key analysis is buffering.
Okay.
Say you have a map of hospitals. You can create a buffer zone around each one to see how many people live within a certain driving distance.
Interesting. So you can see who has access.
Exactly. It helps with planning and resource allocation.
That's powerful. And we briefly touched on raster and vector data earlier. Can you just give me a quick understanding of the difference?
Sure. Think of raster data like a digital photograph. It's made up of a grid of pixels, and each pixel has a value.
Okay.
This is great for things like satellite images or scanned maps.
Makes sense.
Vector data, on the other hand, uses points lines and polygons defined by coordinates. Think of it like drawing with shapes. It's very precise, good for representing individual features like buildings or roads, and it keeps those file sizes smaller.
So each has its own strengths.
Exactly, yeah.
It's incredible how using location as this central organizing principle can connect so much seemingly unrelated data and give us these powerful insights.
It really is. It makes you wonder, how might this ability to link such diverse information through location lead to unexpected discoveries in fields like city planning or environmental conservation?
That's a great question.
Yeah, what new connections become visible when we start thinking spatially about the world around us? I think that's something worth pondering.
It really is food for thought. Thanks for joining me on this deep dive.
My pleasure.
Until next time.